Good morning, friends. I, Professor Tulsi Sham Uda, Cromer Faculty of Engineering. In previous two lectures, we are discussing what is remote sensing, which type of sensor, which type of technologies are there, how the technology developed by year, and type of sensors. In this lecture, we are going to discuss about the uses of remote sensing. There are number of uses of remote sensing for prediction of weather, for agriculture, for environmental impacts, forestry department, geological mapping. Okay, so these are the uses of remote sensing. First, weather prediction. So weather prediction, if we our satellite is very higher with respect to altitude or height, okay, so at that height, that is around to uh, 20 kilometer above the earth's surface, or where the for 100 kilometer the gravitational force is negligible. At that height our satellites are there. From that satellite, our cloud formation is nearer to 8 to 9 km, or 2 km to 9 km area is there for the cloud formation. So that if we go in the hilly sites or hilly area, at that time we can see the cloud formation are very nearer to us, or down down from our hilly area, downward side. So that means the cloud formation is very nearer to this area. In that all cloud formation that is captured by the satellites, and according to that images, they are predicting that the amount of water formation, the amount of cloud formation, the is there, and according to that they are calculate the pressure head, and according to that pressure head they are going to say that according to wind direction they are predicting the weather formatting. So climate or and weather condition are using by the remote sensing satellites. Okay, second things, uses of remote sensing in agriculture. So if the in the some time like monsoon season, heavy rain is there. So if heavy rain is there, the amount of water in farm or in the uh, areas are captured by that satellite camera. Other than that, if some storm or some uh, cyclones are there, so how much area or how much farm are affected because of that particular things, so that is covered by that images of satellites. So survey of the government for giving money to people, needy people, so that is because of that remote sensing type. Another remote sensing is environmental impacts. So here we can see the size, location, direction, magnitude of movement, earth surface movement, that because of why. So in the altitude like 20 or 500 kilometer, if 500 kilometer going with upper with the altitude, at that time we can see the all the earth surface, we can see like one ball. Okay, so in that ball we can see some changes over there, one particular area having some changes over there, so that can be captured by this type of satellites. And geographical condition, we can say that according to what the environmental impact because of the human population are there, that is seen by the satellites. So that is the one uses. Another is a forest inventory. So in forest department, so from that satellite, that is a not like a 500 kilometer, this is required to another satellites which can be put in non negligible gravitational force is there. At that place we can put that, and around 360 kilometer is there. So from 360 km one satellites over there, and they having some specific cameras with it, and from that cameras we can say that the forestry department like cut how much amount of forest went putting at that satellite, or in particular 1 year difference the amount of cutting of trees. According to that we can calculate the data, how much cutting of forest is, or how much amount of required to uh, plantation are required for maintain that environmental impact. Okay, so that type, if some because of some problem in the forest department, or the fire is there, and in nowadays we can see that in Brazil, so all the 50-kilometer areas forest are going to burn. In Australia is there, or nearer to 2 to 3 month, almost 2 to 3 month fire is there in the forest, and because of that so much amount of trees and plantation are going to deplete, the animals, birds, or the wildlife sanctuary also affecting because of that. So that also we can capture by this satellite, and we can put immediate action because of this satellite section, because they are giving some specific areas where the fire is there, where the wildlife sanctuary is affected more than that. So this is very important section for using of remote sensing. Other than that, geological mapping is there. So some type there are many types of minerals in the earth surface, and some are there on the surface of the earth. So if the changing of the generation or the development of the because of our development, there is some changes in the geographical things, or geographical progression of the earth's surface, the folds, lineaments, rocks types, some minerals, some metals. So we can predicting also that that is the things where we are using the remote sensing technology. Now the principal and object identification. Here we can see one stadium over there. Okay, so what happened? So if we directly draw the stadium from at the place, okay, so source and sink were not match. Okay, so what happened if we take that images from the upper head, or with altitude of 2 kilometer or 1 kilometer? At that time we have ideas where we are lacking. So because of the identification of that particular object, the area of that particular object, the how we want to design that particular object, so that is very significance by the remote sensing technology, or the one highway connected to other highways in that area. So in that area also we can using this technology, because we don't know the how much amount of distance is there. First things, if we know the distance, then the which route is going to be a long, or which route will be going to a short. So that is also one thing, that also that type of problem also we are sorting by using remote sensing technologies. Okay, other than that, the size, though the size location also, because it is a very important to recognize the scale of the image to be analyzed. So for that analyzing the absolute size, we can see by the images from by the using of remote sensing technology. The another principal object of identification is image, tone, or color. So how the color is going to reflect or emits the energy or electromagnetic radiation. In most of the cases, the related type of object emit or reflect similar wavelength of radiation. So that type of recording device and recording media pursued image are that reflective of the sensitivity to particular range of the radiation. So that is another things, patterns of the buildings or the cities area. So many objects arrange themselves in typical pattern. This is especially true of human made phenomena. So this is the one, we can say the one area is there, the same pattern is like very dark portion is there. You can see that here very small proportion of houses is there. So how they are looking, so that is one objective. Shadow of that all the images, barabar, how overhead photograph or towering that photograph, so transmission tower. So they are, this is identification is a very big problem. So this identification of that radio transmission tower, smoke stacks, okay, so overhead photograph, because of that overhead photograph some difficulty are there. So these difficulties can be overcome by photographing that object at sun angle. So we can, if we, our satellite or the our whatever device is there, it is between the particular place and the sun, so that's why the effect of shadow is negligible. So that is a sorting of problem. Texture of images also we can say that the texture, okay. So here principal object and identification uses of remote sensing technology. Now the maps and cartography, so scale projection and symbolization is main things are there here. For understanding these things, we are required to one video or their representative fraction, RF means what the images is taken from the earth surface and the what and the image is taken from the satellite. The degree of that two angles are different, and because of that two different angle we can taking the representative fractions. So representative fraction, that also called a ratio, that ratio is the 1 gem 1 by 12,000. So here unitless number is there because both are the same units. So that's why here that's why the unitless things is there. And the demonstrating equivalence verbal, 1 inch is equal to 12,000 inches, 1 inch is equal to 12,000 inches. So that's why we can easily draw in a 1 hour page, okay. So graphical scale is there, some mapping projection is there. From the satellites we can see the conic surface, cylindrical surface, platable surface. So that is design we can show from the altitude. The cylindrical projection over there of the our world from the satellites over there. So how we can see that, so these are the chronic projection over there, these are the cylindrical planar projection is over there. So this is the map symbolization, means line symbol, dotted line, line, big dotted line, double line means rod, one so array is there, array means going outer, dark line, some bridge line. The color phenomena is there, dark color, color pattern is there, color hue is there, how much amount of, okay, point symbol is there. So these are the things where when we are going to map or we are generate some mapping system or particular area or particular state, particular district, particular talukas or particular countries. So these symbols we can see in the map. So these are the system here. Some different countries are there, these are nothing but different countries are there. The Mexico state means white, New York, Mexico is there, this is the dark green type. So these are the USA, most of the USA's countries are there. So we can see that in the mapping system. So these are the mapping. This is a general phenomena of satellite. How the energy transmission means Earth. Sun rays are coming on the Earth's surface. They can be absorbing in the daytime and reflecting at the night time. That we can study in the environmental section in first or second sem. So here the energy transmission, energy radiation, energy emission and energy reflection, these are the topics we can discuss in later chapter. Okay, after that how the energy transmission is there. So there are three type of energy transmission: conduction, convection and radiation. So what the conduction, so when the here general phenomena or the simple terms is there, that I am going to use that. If solid things is there and the energy reflection or absorption is there, that means conduction. If the liquid section is there, that means convection. And if the gas transmission or the wavelength is there, that means the radiation. So these three things are there. If solid is there, then conduction. If liquid is there, then convection. Or if the gas transmission or my voice is coming to in air, okay, or one place to another place, that is a one type of radiation. So only gas transfer is there, that means radiation, that is measuring in the wavelength. So these three things is there. Here the electromagnetic radiation is there. So we can see that in physics some graphs like this, the avruti, magnitude and electromagnitude. So this is the same graph. This is the symbol, the wavelengths, we can say by the lambda, how much wavelength is there. So okay, so this is not as much important, but the important is the Planck formula. The Max Planck's formula is there. C is equal to lambda v. What is C? So C is the speed of light, 3 into 10 raised to 8 meter per second. We can studied many time in our science, 11 12 science, in chemistry, in physics. C is a, जिसे बोलते हैं हम प्रकाश की तीव्रता, प्रकाश वेवलेंथ. ओके, तो it is a 3 into 10 raised to 8 meter per second. Other than that, lambda is what? The lambda is the wavelength that is measured in minute. And if we can predicting the energy transmission from the sun, so there is no medium present in the sky to earth. So that's why the gaseous medium or the air particles, we can assume that that's why the radiation process is there. V is the frequency, so cycle per second. So here we can see that in this graph one periodic cycle is there, so where the starting point and same lines points second time be there, so that is a one cycle. So that type of cycle, so that we can in hertz frequency. So C is equal to lambda into V. So what is V? So V is frequency is inversely proportional to lambda. Here we can see that C is a proportional to lambda, but what is actual? So V is if V is we can use V is equal to C by lambda. That means V is proportional to, inversely proportional to wavelength, and longer wavelength the lower frequency, means the wavelength high, then the frequency is going to low. If the wavelength is low, then frequency is going to high. So that is one thing. Type of EM wavelength, so different type of our wavelength, like their infrared wavelength, ultraviolet rays, visible rays, radio waves, microwaves, radar, lidar. So that we can study in 10th standard. Okay, so unit measure the 0.01 meter in radio wavelength. Microwave length means 0.001. Infrared, very small wavelength, or infrared wavelengths means the nearer to X-ray technology. Okay, so that technology we can say the harmful to the human body because of what? So it's short wavelength. So 10 raised to minus 6 meter means micrometer. Okay, visible wavelength means nanometer, 10 raised to minus 9 meter. ultraviolet rays 10 raised to minus 10 meter means 1 angstrom is equal to 10 raised to minus 10 meter. So ultraviolet is very short wavelength, and we can say that the sun emits so much ultraviolet rays on the earth's surface, but because of the ozone layer, the ultraviolet rays are going to absorb in that medium. That's why they are not coming to the earth's surface. If that ultraviolet rays are coming on the earth's surface at that time, so much disease or the skin cancer are there, or the plants burning or process is there. So that is a very dangerous to human beings. So that's why we are thankful to ozone layer. Here the wavelength or short wavelength or that wavelength frequency chart is there, so you can see that from that images. And here the in GTU, so there is a no question asked like this, because objective question are not there. But if you are going to cracking some other exam or government exam after passing the engineering, so at that time this chart is a very important one. Question is compulsory asked. Okay, this is the chart, the range of the wavelength and which type of rays are there. So we can say that long radio waves range, so that is 10 raised to 4 to 10 raised to 6. So that means 10,000 to 1 lakh, so 10 lakhs is there. So that is a very long wavelength. And we can see other, so gamma rays is there, so very minus rays. X rays is there, so 10 raised to minus 10, 8 to 10 raised to minus 12. Ultraviolet rays very short wavelength. Visible rays also nanoparticles like very short wavelength. Infrared very short wavelength. Microwaves is also very short wavelength. So we can see this chart, the frequency cycles per second over there. So according to that rays, if we can see 10 raised to 10, that means the gamma rays is there. Gamma rays is not there, but very long wavelength is there. The wavelength is 10 raised to minus 6, means the visible rays 10 raised to minus 6. This is in this chart we can see visible rays. The visible infrared rays, if the wavelength is very small, the frequency you can see the 10 raised to 14. So 10 raised to 14 means 1 crore into 1 crore. So that amount of frequency very much higher is there. If we can short wavelength, so we can easily say that the wavelength is inversely proportional to frequency. Okay, so here the same chart is there, so that is the same chart. Okay, here the our we discussed earlier, the sensor is there on the upper altitude on the earth surface, and they are capturing the images from the earth surface, or sun rays are giving the energy to the earth surface, and the sensor also, the sensor also put some wavelength on the earth surface also, on the earth surface absorbing something and transmission or reflecting that to the that sensor, or scattering some medium, that is things. So other these things, the scattering, absorbing, reflection, transmission, all these terms if we understand, after that we understand this chart very easily. So these things we will discuss in next lecture. Okay, and these things, the wavelength frequency, it is very important for you in your exams, GTU exams not, but if after passing the engineering, the government exams is there, so at that time this is very important for you. The diameters also in meter, or if you all are engineering students, so you aware about the its own name, like if 10 raised to minus 9 is there, that means 1 nanometer is there. So you can easily rememberize one equation is there, फेपी ने मामी छेड़े पेटे घी में की हेडे, ऐसे करके एक इक्वेशन आता है, वो हम अगर लाइव क्लास में मिले, और इफ़ यू आर नॉट एबल टू अंडरस्टैंड दिस, देन वी कैन for understanding this concept, we are organize some two in within this week. I will give one link over them for Google video is there. So in that Google video you are coming and ask me if you have some query or problem related to this topic. Okay, thank you very much.